Chapter 4, Linux File System Management, Part 3. In this, our third and final lecture on Linux File System Management, we're going to be looking at file and directory permissions. Now, this is really the whole reason why Linux as an operating system exists, right? Why was Unix developed as a multi-user operating system back in the late 60s? It was to provide better protection for people's data. So I could keep my files away from you, and you can keep your files away from me. Well, we do that through permissions. In order for permissions to have any meaning, though, we have to have discrete users, hence the term multi-user operating system. So let's define a few things first. What is a user? Well, in a couple of weeks, we're going to be spending a lot of time getting into what users are. But for right now, it can suffice to say that a user is a discrete person who has a login to the operating system. Right? So I'm a user, you're a user. There's all kinds of different users. There's software can be users, but we'll get into that later. Human users log in with a username and a password, right? This is how they authenticate. This is how they prove who they are. Once they've authenticated, then they are authorized to do certain things. And part of that authorization comes from the permissions assigned to them. We also have this concept of groups, right? So what is a group? What's going on with that? Let's take a look at this for a minute. Let's say we have a company, right? And out on our file server, we have a folder out there for human resources. There we go. Human resource folders are full of all kinds of employee information, their health information, payroll stuff, all this type of stuff you don't want everyone else in the company getting a hold of. So access to this HR folder is restricted to the HR employees. Well, let's say I have 11 HR employees, right? There's an employee right here, and this is Bob. Bob joins HR. So what I have to do is assign Bob's user account permissions to this HR folder. And I have to do that for every one of my other HR employees. This is going to be a pain in the butt with 4 or 5 employees. With like 11 of them, it's going to become difficult. How about 100 or 500 employees? It becomes untenable. Bob leaves. Bob quits. He leaves. Right? So I have to go in and remove his permissions, or maybe he moves to a different department and no longer has access to this anymore. Maybe we bring in a new employee. We're going to bring in Susie, so we have to add permissions there. It becomes a pain. So one way around this is the idea of groups. And groups are really nothing but containers and they hold user accounts. So what I do is I create a group called HR. Right? And then I assign permissions to the HR folder, not to individual users, but to the HR group. Now, all I have to do is take my HR users and without setting any other permissions on them, put them in the HR group. When they go into the group, they automatically inherit the permissions given to the group. Let's say we fire Bob. Bob, you're out of here. If I take Bob out of the HR group, he loses those permissions. I don't have to change individual user accounts. I just have to change their membership in whatever groups they're in. So all operating systems do this. All modern multi-user operating systems do this. We have groups. Linux is no different. And we have several different kind of groups. We have what's called a primary group. Now, every user is a member of at least one group, and that's that user's primary group. As we'll see in a future week, that user's primary group is usually a group made just for them. And we'll see that here. Our user Bob has a group name called Bob, and we'll see that. There's also secondary groups, and I can be as a member of many secondary groups as I want, but I at least have to be a member of a primary group. Okay. So here we are on our Linux CLI, And you notice I'm logged in as Bob. And that brings our first command. A lot of times there's some confusion. What user am I, right? You're trying to do something and you're like, I should have permission to do this, but it's not letting me. What's going on? Well, maybe you're not the right user. If you type in the whoami command, that tells you your username. Oh, you're logged in as Bob. Now, I know our prompt here tells us that, but you don't always necessarily have this bash prompt. So if you issue a whoami, that'll always tell you what user you're logged in as, what context you're speaking from. Another command we have, and I alluded to it in a previous lecture, is called the touch command, right? Last week, we were in there with the Vim editor, creating text files. We were looking at as ways of creating a file and putting content in it. Well, I have another command that goes in and creates a file, but doesn't put anything in it. And I know that sounds kind of useless, but it's really useful for a lot of different things. And it truly creates the file. It goes out and grabs space on the disk, it grabs some blocks, it'll grab an inode, it'll associate a label to that inode, whole 9 yards. There's just nothing inside the file. So let's say, if we're looking here in Bob's home folder, I've got file 3 and file 1, and I want to make file 2. I simply touch file 2. Now if I do a long listing, oops, here's file 2, right? It's a file, it's right there, it's got permissions on it, a whole 9 yards, but it has nothing inside of it. Now I could Vim file 2 and go in and populate stuff. I could do some folder redirection, which we'll talk about later, but I have created that file. It's real in every sense. Let's say I want to change my ownership, right? Because every file, and did I ever mention that everything under Linux is a file? Everything under Linux is a file. We keep coming around to that, including directories, right? But they're a special file. So we're going to see how these permissions affect directories slightly different, but they're still files. So keep that thought straight. So every file has an owner, right? How do I change the owner? Well, I have a command called chown. And if I do a long listing, like I just did here, let's see what it tells us. Here's my file name right there, right? The date and time it was created. And then these two columns right here, this first column is the user who owns the file. In this case, it's Bob. The second column is the group who owns that file, also the Bob group. Like I said, when you create a new user, by default, a primary group is created for them with their same name, and that user becomes a member of that primary group. Now, off to the left here, we have our actual permissions. This is called the mode. We'll spend some more time with that here in a minute. So Bob owns everything. What if I wanted to change ownership? What if I wanted to take file 2 and give it to a user named Susie? Well, I can totally do that, right, with the chown command. Thing is, I can't chown as Bob. I can't assign someone, a regular user can't assign another user a file, but root can. So I'm very quickly going to switch over to root. All right, here we go. Let's clear that screen. Let's do a long listing again. Oops. Need to go to Bob's home directory. Now, don't worry what's going on here with the whole switch user thing. We'll talk about this in a future lecture. There we go. So I'm sitting here in Bob's home directory, and there's file 2, and I want to give it to Susie. Well, I can chown, right? Change owner. That's what that command means. And I tell it, who's the name of the person it's getting? Well, I created a user on this system called Susie. And then the file that we're giving to her. Now look what we have. Permissions are the same, file metadata is the same, the date timestamp, but look at the owner. Now it's Susie. The group is still Bob, right? All I did was change the user. Now I can totally change the group also with the same command. And I do that by specifying user and group by putting a colon in between them. So chown to the user Susie to the group Susie file 2. Now notice she owns both of them, right? Or rather, both the user and the group Susie owns the file. We can assign it to whoever we want, right? Let me do the opposite. Let's put it back to Bob as the owner. But leave it in the Susie group. See how we did that? Now I'm going to put this back. Let's give Bob his file back, because we'll be working with this file here in a minute. Oops. Change ownership to user Bob to group Bob of file 2. There we go. There, and everything's back to where it was. Now let me go back to the user Bob. There we go. Now, one thing that the chown command can do is work recursively. So let's say I wanted to, as root, I wanted to give an entire part of the directory structure from one user to another. Maybe I had a user quit, an employee quit, and I gave that user's home directory, that former employee's home directory, to another employee who took over that person's job position. They might have had 15 different levels deep inside their home directory with thousands of different files. Well, I could go and do every one individually, which would take like years, or I could do it recursively with the -R option. And that is simple. And notice that's a capital R. Chown -R, user, group, and then I just give it, let's say, that person's home directory, and it'll recursively go through the entire directory tree at one time, chowning from one user to another. Warning, this recursive option can be dangerous. You can inadvertently chown things that you didn't plan on chowning. All right, let's get to the meat of this. File and directory permissions, what they actually are. Well, we looked at them, right? Over our long listing, the little RX, W, RX, RX, what was going on with that? Well, that's called a mode, right? And that's actually part of the inode. Remember, the inode stored all this metadata about a file, its characteristics. Well, this part stores the permissions to it. And the mode is broken up into 3 separate sections. It's one set is the user, the user owner permissions, the group owner permissions, and then everybody else on the planet. So it kind of looks like this, right? The entire mode right here is what we saw, broken out into 3 pieces. First the user, then the group, then everybody else. Now everybody, or all these sections, have 3 permissions you can assign to it. I can assign a read permission, a write permission, or an execute permission. And I do this separately. So read, write, execute for user does not necessarily mean read, write, execute for the group or for everybody else. I have to set each of these explicitly for each section of the mode, right? Let's talk about what this even means, right? What's read mean? Well, in terms of talking about it to a file, read has a slightly different effect than it does to a directory. All these permissions do, really. I know I said before that, yes, directories are a form of file, and they are, but they're a special file. So read, write, execute assigned to a directory has a slightly different effect than assigned to a file. Right now, let's look at read, write, execute for just a file, right? Reading a file is obvious. It allows a user to crack it open and look at it, right? It allows me to cat or less or more a file. A write permission allows a user to open, read it, and write to it. right? I can make changes to the file. The execute permission allows me to run that file. Remember, files can be executable. They can be binary executable files. They can be shell scripts. We'll be doing a lot of those later on. When to get them to run, you have to set the execute bit, right? How about for a directory? What goes on there? Well, if I give a user read permission to a directory, it allows that user to list the contents of the directory, right? If they don't have read permission, they can see the directory, but they can't see what's inside of it. Likewise, a write permission to a directory allows a user to add or remove files to it. Execute permission on a directory allows users to actually enter the directory and work with it. So for a directory, in order for these read and write to have any meaning whatsoever, you also have to assign the execute permission. Read, write, execute for the owner. Read, write, execute for the owner group. Read, write, execute for everybody else. And if we look at our file system here, we totally see this, right? Look at the permissions for file 2 that we just created. Owned by Bob and owned by the Bob group. The owner, and this first character right here is a special character. We'll talk about this here in a minute. That defines other things like directories, whether it's a directory or not, or a linked file or whatever. File 2 has the owner, Bob, this guy, can read and write his file. Members of the Bob group can also read and write that file. Everybody else in the universe only has read permission. Those little dashes right there mean the absence of a permission. Right? It's always 3 fields for each one of them. Your permission part, the permission part of the node will always have 9 fields total. Read, write, execute, read, write, execute, read, write, execute. It's just a matter if you turn them on or not. Right? They're Boolean. They're either there or they're not. Okay. Notice how this contrasts to file 1. File 1, also owned by Bob, has read, write, execute. So Bob, the user, can read this file, write that file, and run the file. Bob, the group, members of the Bob group, can read the file, and they can execute the file, but they can't write to it. Everybody else in the universe has no permissions to it. They can't even crack it open and see what it does. So my file permissions can be different from file to file, directory to directory, whatever, and they frequently are. File permissions, at least in my experience, have been one of the #1 leading causes of user problems in Unix operating systems. In any operating system, really, but especially in Unix operating systems. A lot of times when your phone rings, a user's having a problem, they're trying to get something done, they can't do it, it circles back around to permissions. So if that's the case, how do we change permissions, right? We're going to be doing a lot of this. You do it for your own files. As the administrator, you're going to be doing it for all kinds of other people, right? That's what you're going to be doing. You'll be going in, looking at permissions, and trying to fix them. We have a command for that. It's called chmod, which is change mode, right? The mode is that security piece right there that defines our permissions. And there's 2 different ways I can use chmod. One way is with a relative use. So basically I would chmod, and then for the user category, do like a plus or minus read. For the group category, plus or minus write, whatever. I'm personally not a huge fan of this method because it's kind of messy, and it's got a lot of syntax to it, and it's quite frankly easy to mess up. The second method of using chmod is to explicitly define the permissions using an octal value. Well, what's octal, right? It's base 8. It's any number 0 through 7. And quite frankly, if you can add 3 numbers together, all of them less than 8, then you know how to do this, right? This is very straightforward. It's very obvious to what you're doing. So this is what we're going to focus on. We're looking at our mode right here, right? The user section, group section, other section. Each one of the permissions, read, write, execute, is assigned a decimal value. Actually, excuse me, an octal value, right? Read is assigned a value of 4. Write is assigned a value of 2. Execute is assigned a value of 1. 4 plus 2 plus 1 equals 7. So if I assign permissions of 7 to, let's say, the user section here, then that user owner is going to receive read, write, execute permissions. If I assign a value of 5 to the group ownership, let's say, they're going to receive, and there's only, out of these 3 values, there's only one combination that gives me 5. That's 4 plus 1. They're going to receive read permissions and execute permissions. They will not receive write permissions. Let's say for everybody else on the planet, I assign 4, a permission value of 4. They'll get the read permission, but nothing else, right? And I can assign this in all kinds of different orders. But check it out. This table right here breaks it out. So if I want to assign read, write, execute, you give it a 7. If I want to assign read, write, well, I give it a 6, 4 plus 2. If I want to assign read, execute, give it a 5, 4 plus 1. These are our most common ones. And read only, right? If I just want to give it somebody just read access, I assign them a value of 4. I can totally assign all these other ones too. I can give somebody just write access if I choose to, with no permission to read it. But it doesn't make a lot of sense. I mean, just because you can do it doesn't mean you should. Notice down here at the bottom, if I assign a value of 0, I take away all permissions from that particular part of the mode, the user, the group, or everybody else. So using chmod with an octal representation of each of the permissions allows me to really explicitly do this. Let's take a look. So I'm back here. Now, users can do this over the files that they own, right? We can't chown our files to somebody else because the other person may not want them. But I can totally change permissions in my own files. Look what we did to file 2, right? Read, write, read, write, read. Let's say I want to give... So we want to do this. So let's chmod. And then I give the octal values. So I'm going to give it a 777 file 2. Now if I do a long listing, check it out. Read, write, execute, read, write, execute, read, write, execute. I've completely opened this file up, wide open. Anybody on the planet has permission to read it, write it, execute it, delete it, whatever. Don't do this a lot, right? 777 is useful for troubleshooting things, but you don't want to leave your stuff like this. Unfortunately, it's the lazy admin's way of fixing problems, and very frequently you'll see file systems full of 777s. Guess what part of your new job's got to be? Fixing that. I can do a little more. Let's say I want to chmod 755 on file 2. Now I've given Bob the owner read, write, execute, Bob the group read, execute, everyone else in the world read, execute. See how we did that? One more. Let's say I don't want anyone except the user or the group user to have access to this file. Let's do a 750. Now, file 2, read, write, execute for Bob. He owns it. He should be able to do whatever he wants to it. Read, execute for Bob, the group, and everyone else has no permissions to it. Now, chmod also can work recursively, right? It's just like a chown could. I could go to the top of a directory tree, issue a -r, say, and do something like this. Oops. And that'll go through. Forgot my settings here. And reset everything from in Bob's home directory on down, no matter how many thousands of files are in there, no matter how deep it goes, to 777. Like Chown, doing this recursively can be dangerous. So you definitely want to be paying attention when you do this. You notice when I touched that file, it came up with permissions, right? It came up with like read, write, read, write, read, write. How does it know that? It does it through a value known as a umask. That's how the Linux system knows what permissions to give new files. Now, umask is a command, but it's also a setting out in the system. And it's a subtraction, right? If umask was not there, every time you touch a new file, it would automatically get 777. But the umask, and it's expressed in values like this, so 022 is a very common one, is a subtraction value. The system says, okay, anytime somebody touches a new file, whatever permissions it's going to have will be 777 minus the umask. So in this case, 777, read, write, execute, minus 022, right? Let's take a look at that real quick. Now, the system-wide umask is set in a file in the Pt3 folder. Because remember what the Pt3 folder is, plain text configuration files, right? And if I scroll down, there's a file in here called Pt3 profile. P. There it is right there. Pt3 profile. And if I cat that file, it's got a bunch of other stuff in here, path name, stuff like that. But look at this section. This is the part that sets umask for the system. And what it's actually saying, this is actually a shell script, what it's actually saying is if your user ID is greater than 199, right, which is a regular user, then you get a umask value of 002. So 002 is subtracted from every new file that's touched. If your UID doesn't fit that, meaning you're a root user, then you get a umask of 022. And there's other umask values set too. I can set it individually in user files, in some of the hidden files in your home folder. But this is the starting point in the system, right? Now, one thing you may have noticed was those permissions were very broad. And compared to like a Windows system that has very granular permissions, these are definitely large. Or yeah, they cover a big space. We do have a few things that we can do to tweak that a little bit. Some of them are called special permissions, right? And this is where I can tweak my permissions just a little bit to make things behave slightly differently. And we have three of them: set UID, set GID, and the sticky bit. Well, that sounds messy. The set UID. Now, this only works on executable files. It is only applicable to executable files. What this happens is, let's say root owns an executable file, right? And you're a regular user, you're Bob, and you have execute permission on that file, and you go to run it. Well, what's going to happen is that program is going to run with the permissions of Bob. It's going to run under the context of the user Bob. Maybe the user Bob doesn't have the necessary permissions for that program to do what it needs to. Well, if I set UID on that program, set UID root, then Bob runs it, but this time when the program runs, it runs under the context of root. It has root's permissions. When the program finishes executing, then those elevated permissions just go away. Well, there's some obvious real problems to that, and one of it is security. Right? A regular user could do a lot of damage to a system running programs that run under the context of root. So there's some cases where this has to be done, namely with the password command, which we'll learn in a future lecture. But it's definitely, you want to use this very sparingly. You need to use this when you have to, not everywhere. GID is the same way, right? Except it runs under the context of that group owner instead of the user owner. And it also inherits the same security issues. Now the sticky bit is a little bit different. The sticky bit allows only the file's owner to delete a file. Let's see what that looks like in here. Let's go back to our HR folder. And you know what? Let's clear that. Let's start over. Maybe our company has a shared folder on our drive, and we're going to call this TPS reports, right? And permissions on this folder are set to 777 because we want everybody to go in and save their TPS report to this folder right here. And at the end of the day, all our employees start putting them in there because everyone has write permissions, right? So here's Bob's TPS report and Susie's TPS report, Ethel's TPS report. Well, here's the problem. I have 777 in that directory. So I could go in and blow away Susie's TPS report. Maybe I don't like Susie. Maybe I want to get her fired. So what I do is I sit there, wait till the end of the day. I watch her save her work, her TPS report. It shows up in the file. She gets up, grabs her coat, walks out the door. I go in and I delete her file. Now the next morning she comes in, the boss is at her cubicle saying, hey, where's your TPS report? Why don't you pack your stuff? Well, the sticky bit prevents that. If I set a sticky bit on a directory, right, and sticky bit can only be set on a directory, if I set this on a directory, then even though I might have read and write permissions to Susie's TPS report, I can't delete it. Only Susie can delete it. So it's not a perfect solution, but it's better than letting everybody have access to everything else. So how do we set this? Well, we can set it with the chmod command, just like we do regular permissions, right? When I set any of these, and we'll demonstrate this here in a second, how do I know I set UID? Because in the mode, if I set UID under the owner section, the execute bit becomes an S. That stands for set UID. If I set GID, then the group execute position becomes an S. If I set the sticky bit on a directory, then the all others execute becomes a T. See that? That's the only time those are going to be there. How do I do this? Well, I would set this using the chmod command. And again, it uses those octal values. Only instead of the 3, right, 777, this is a prefix. So if I don't put anything in this first column, call it the fourth column if you will, but it's the first one, then just special permissions aren't applied. But if, let's say I put a 4 on here, then I'm going to set UID that file. If I put a 2 in here, I'm going to GID that file. If I set a 1, I'm going to apply the sticky bit. And just like the rest of the permissions, I can stack them, right? So let's go back to our command window. We'll go back to Bob's home. So just for giggles, let's set, now we'll call these executable files. I mean, these set UID, set GID won't do anything, but we'll get to see the effects. So I'm going to set UID on file 3 here. 4, right, that sets the set UID value. 755 file 3. Let's see what I got. Well, first, file 3's changed color here in the bash shell. It won't always do that depending on what you're using to access the system. But look under here under permissions. owner permissions are now RSW or RWS, which means set UID has been set on file 3. So anyone who runs file 3 will run it under the context of Bob. Let's say I do this. Notice what I just did. Now I give it a 6. Now I've set UID and set GID on this file. Any user now who runs it will run it under the context of Bob and under the context of the group Bob. And the least restrictive set of permissions will take apply. Maybe I just want it to be under the group. Slightly different color here, and notice now that my group permissions have been set. There's one last piece of this, and it's called the access control list. Under Windows, right, we have very, very granular permissions we can set on things. The standard Linux permissions are very broad in comparison. Well, the reason they're so broad is those permissions date back from the original Unix, which dates back from the late 60s. Security wasn't the concern back then, it is now. Linux has grown with it, though. And if I want to, I can set more granular permissions on my Linux files. But I have to use something called an access control list, right? We don't do this very often, but it comes in very handy when you need to. And we're just going to take a quick look at it. Now, every file has an ACL assigned to it. It's a default ACL. We're going to take a look at one here in a minute. And there's two commands that we care about for dealing with ACLs. We have setFacle, which is set file ACL, where it's used to modify the ACL entries. And I have the getFacle command, which will tell me what those entries are. So let's clear our screen. And let's say I want to see what the ACL is of file 2. Notice my permissions under file 2. Read, write, execute, read, execute, and nothing for anybody else, right? So this is a 750 permission. If I get Facle, file 2, there's the ACL applied for file 2. And it's the same as the Linux permissions, right? But using an ACL, I can go in there and add Susie, let's say. I could do a setFacle and give her read, write, execute, but nobody else. And I can do this to users, to groups. It can get very, very linear. And that concludes our rather lengthy but comprehensive discussion about Linux file permissions. As always, if you have any questions, please feel free to reach out to me, and I will see you next week.